Today we're going to solve linear systems algebraically, which is a lot nicer in my opinion than solving graphically like we did in the last lesson, because we don't have to draw graphs and we get exact answers. So we're going to see two equations, and our first step is to solve one of the equations for one of its variables. That means get x or y by itself. We then substitute that x or y value into the other equation and solve. That might sound a little confusing right now. You'll see in the first example what I mean. Once we know the first variable, we can go back and substitute again to figure out our remaining variable. So let's take a look. Look at this yourself and try to decide which letter would be easiest to get by itself. It could be any of the x's or any of the y's. Hopefully you chose that x. That's the easiest one to get by itself because it won't require any dividing. We can do one step and we have x by itself. The substitution step comes from taking that x value and plugging it into the original equation. You might remember doing this in Algebra 1. Instead of 2x, we get 2 times whatever x is, plus 5y equals negative 5. In place of x, we're putting negative 3y plus 3. At this point, we can use some basic algebra to solve for y. Once we know y, we're not quite done because we also need to know x. To figure out x, we can go to either one of the original equations, plug that y in, and we'll figure out x. I'll choose the second one, no particular reason, it just looks a little easier to me. X plus 3y equals 3. Of course, y is 11. So we go through some basic algebra to solve for x, and we get negative 30. At this point, we're technically done, but we should write our answer a little nicer. We can write our answer as an ordered pair. Negative 30, comma 11. On a quiz or test, you can always go back and check your work by plugging negative 30 in for x, 11 in for y, into both equations, and they should both work. Notice this was a lot faster than graphing. Also, you probably wouldn't want to draw a graph where you have to go all the way out to negative 30 to find your solution. So solving algebraically is just a little nicer and overall in the long run. The other method we learned for solving systems of equations is the elimination method. This is where we try to cancel out the x or the y by multiplying the equations by something. You'll see what I mean in the next example if that doesn't make sense. Once something cancels out, we can solve for x or y without too much difficulty, and then just like the last example, go back and plug in to figure out our missing variable. So we're going to try to cancel something out. 3x and 6x don't look like they cancel out right away. So what you have to ask yourself is, what number do 3 and 6 both go into? And they both go into 18. You could also ask yourself, what do 7 and 8 go into? The smallest number is 56. My advice is to always go with the number that's smaller. 18 is definitely smaller than 56. So I'm going to make my x value is 18. To get 18 on the first one, I have to multiply everything by 6. To get 18 on equation 2, I have to multiply by 3. But since I want these to cancel out, I want a negative 18, so I'll say negative 3. Now I multiply everything by 6 on the top one, get a new equation. And do the same thing for equation 2. Notice I have 2 new equations now, and the x's look like they cancel out top and bottom. 18x and negative 18x cancel out. Negative 42y and positive 24y go together to make negative 18y. And 36 over here. One more step gets y by itself. And congratulations to anyone who caught my mistake. I made a mistake earlier, but I caught it now. 18 was actually the wrong number. There is a much smaller number that 3 and 6 go into. I could have used a 6 there instead of an 18, and it would have made the whole problem a little easier. But choosing a number that's too big is okay. You would have still gotten -2 for y. So, whoops on my part. At this point, we go back to the original equations. It doesn't matter which one. I'll choose equation 1. I know y, I don't know x. Go through some simple algebra steps here, and you find out that x equals a -4/3. And we write our answer as an ordered pair. That's how we know we're done. Notice how hard this would have been to figure out by graphing. Finding -4/3 on the graph and being that precise would be actually really hard. But using algebraic methods, we get exact answers that we know are right. As always, go plug these back into the original, especially if it's a quiz or a test. At this point, you can pause the video, try these on your own, or you can do those later. All right, pause the video, read the problem, make sure you understand what's going on, then we'll talk about it. Looks like we want to know how many short sleeve shirts are sold. We can call that X, which makes Y perhaps the other thing that we don't know, number of long sleeve shirts that are sold. We've got enough information here for 2 equations. We know that the cost of the short sleeve shirts is $5. So we're going to say 5 times the number of short sleeve shirts plus 7 times the number of long sleeve shirts is going to be how much money we spend total. And it tells us that we spent $2,500 total. Our second equation comes from what we're selling. We're selling short sleeve shirts for $8 each, so we can say 8x. And we're selling long sleeve shirts for 12, so we can say 12y. And we're going to sell all of them for $4,200. You could probably guess this wouldn't be very fun to solve by graphing, but elimination is not going to be too bad. My first step is always to ask myself, what number do 5 and 8 go into? 40. What number do 7 and 12 go into? I don't know off the top of my head, but I know it's definitely bigger than 40. It's 84. So I'm going to go with the 40. I need a 40 and a -40. So that's going to be my first step in the solving piece. I want a positive 40 up top and a -40 on the bottom. So let's look at what that gives. At this point, we get the elimination of the x's, and we see we get 4y equals -1,000. -4y equals -1,000. Y equals 250. Now we have to be careful. Y was the number of long sleeve shirts sold. Go back to the problem. It's asking how many short sleeve shirts were sold. So we got 250, and 250 is one of the answers, but that's a trap. 250 is how many long sleeve shirts we sold. We want to find out how many short sleeve shirts we sold, which means I got to go back and solve for x. It doesn't matter which equation I plug into. I'll choose the first. We know y is 250. At this point, we use some simple algebra steps to just solve for x. Turns out x equals 150. Make sure you can do those steps if you're not sure about it. Then we get our answer. Multiple choice test writers love to put answers there that trick you, and this is a perfect example of that happening. At this point, you can pause the video and try this on your own, or you can do that later. Okay, for our next example, and our last example for this lesson, we're going to solve linear systems with many or no solutions, and we'll see what that looks like. If you remember, many solutions means that we have the same line on top of each other, so we get an infinite number of solutions. No solutions happens when the lines are parallel. We can't really tell if that's happening in either of these just by looking at it necessarily, so we'll just use elimination method and see what happens. Looking at part A, it looks like I can use 3 or 6 as my number. I prefer small numbers, so I'm going to make the top equation -3, the bottom give me the +3. Let's see what we end up with. We can see the x's cancel out. We see that the y's happen to cancel out this time too. We end up with 0 equals -4. We all know that's not true. That's an example of no solution. That means these lines were parallel. If you don't believe me, you can graph those lines and see for yourself. Those are parallel lines. We'll do something similar for this next one. 4 and 14, the smallest number they go into is 42, I believe. I lie. They both go into 28. I could have used 42, it would have worked. You'll just give me bigger numbers. 10 and 35, I don't care what they both go into. It's definitely going to be bigger than 28 because 35 is already bigger than 28. But if I want to get 28 and -28, I need to go 7 and 2. See what we come up with. Just like part A, the x's and the y's both cancel out and we get 0. The difference of part A is we also get 0 on the other side. This is always true, so this is an example of when we have the same line twice. So this is many solutions. Again, if you want to check to see if these are the same line twice, you can always go graph them yourself and see. At this point, you can pause the video and try these on your own, or you can do them later. Other than that, we are done with this lesson.